Megascale engineering is a form of exploratory engineering concerned with the construction of structures on an enormous scale. Typically, these structures are at least 1,000 kilometers in length, in other words, at least 1 megameter, hence the name. Such large-scale structures are termed megastructures. In addition to large-scale structures, megascale engineering is also defined as including the transformation of entire planets into a human habitable environment, a process known as terraforming or planetary engineering. This might also include transformation of the surface conditions, changes in the planetary orbit, and structures in orbit intended to modify the energy balance. Astro engineering is the extension of megascale engineering to megastructures on a stellar scale or larger, such as Dyson spheres, ring worlds, and Alderson disks. Megascale engineering often plays a major part in the plot of science fiction movies and books. The microgravity environment of outer space provides several potential benefits for the engineering of these structures. These include minimizing the loads on the structure, the availability of large quantities of raw materials in the form of asteroids, and an ample supply of energy from the Sun. The capabilities to employ these advantages are not yet available, however, so they provide material for science fiction themes. Quite a few megastructures have been designed on paper as exploratory engineering. However, the list of existing and planned megastructures is complicated by classifying what exactly constitutes a megastructure. By strict definition, no megastructures currently exist. By more lenient definitions, the Great Wall of China counts as a megastructure. A more complete list of conceptual and existing megastructures, along with a discussion of megastructure criteria, is found under megastructure. Of all the proposed megastructures, only the orbital elevator, the Lofstrom launch loop, and Martian or lunar space elevator concepts could be built using conventional engineering techniques, and are within the grasp of current material science. Carbon nanotubes may have the requisite tensile strength for the more technologically challenging Earth-based space elevator, but creation of nanotubes of the required length is a laboratory exercise, and adequate cable-scale technology has not yet been shown at all. The assembly of structures more massive than a space elevator would likely involve a combination of new engineering techniques, new materials, and new technologies. Such massive construction projects might require the use of self-replicating machines to provide a suitably large construction crew. The use of nanotechnology might provide both the self-replicating assemblers, and the specialized materials needed for such a project. Nanotechnology is, however, another area of speculative exploratory engineering at this time.